All right, here's the second video to go along with the packet. And this is just so what I need you to do is pull out your calculators and we're going to enter in the times and the heights. So to enter in data in your calculator, you're going to hit Stat and enter. 1, I'm going to enter in the first column. And enter in the second column into L2. All right, so this problem is talking about a tennis ball is just tossed up and its heights at various times are recorded in this second column that we put into L2. And the first column is the time that it took to reach those different heights. So it says use the quadratic regression feature on your calculator. So not linear, but quadratic. So first let's go ahead and make a scattered plot, okay? Because that helps set our window for the regression model if we have to look at our calculator. So in order to graph, I'm going to get out of this mode. I like to always hit second quit. And I need, remember that I said the word is stat? I need to turn a plot on. So you go second y equals, where it says stat plot, and then hit enter twice. So now a plot is on. So now if we want to graph the scattered plot, I just go zoom, and remember you got to find stat, and if you work your way down, it should be zoom 9. And there's our scattered plot. So it definitely has that feel of a quadratic. It's not linear. You got points going up and then coming down. So let's go ahead and find the regression model. So we're going to go, keyword is stat. So far we've done stat plot, zoom stat, and stat. So to make the regression model, we'll go stat, calc, and then we want the regression, not linear this time, but quad regression. So that's option number 5. And I'm going to show you how to store the regression model, but in a minute, let's just go ahead and calculate it. All right, so I'm going to round these to 3 decimals. Now this is in terms of t, not x's. So we'll put -13, and let's round it to 3. Okay, -13.724 t squared. Now look, they told you here it's ax squared plus bx plus c, but ours is t's instead of x's. Plus 6.232t plus 1.979. Now you can type that into your y equals if you want, but I'm just going to show you how you can let the calculator just pop it in for you. So if you, now that these are rounded and what we're going to put in is exact, I'm just going to show you how to have it, put it into Y1. So if you hit stat and then calc, and number 5, do you see where it says store regression equation? If you want to tell the calculator to put it into Y1, all you need to do is hit the vars key, V-A-R-S, and then go over to Y vars, and then hit enter twice. See, you're going to tell it to put it into Y1. And then calculate. And then watch, if I go into Y equals now, that popped it right into Y1. So that's nice. You can go back and look at the video again on how that was done. But to find the Y1, you want to go to vars and then function. Okay, so now when I look at the graph, hit graph, you can see how lovely, right, that model is. Now, all of these questions are based off of this model. So it says, using your model, find the F-intercept. All right, F-intercept and Y-intercept are the same thing. So that's when time is equal to 0. If you're a Y-intercept, you have a Y value, but the input is 0. Okay, so if t equals 0, do you see you're left with just 1.979. Now, it's not exactly, right? This is just a model. And you can see it doesn't hit it exactly, but it's just a good estimation, right? It's just a little estimation. So that's what the model says. And according to the model, the ball was 1.979 feet above the ground before it was released. Okay? All right. So it says, use your calculator, find the T-intercepts. All right. The T-intercepts are like the X-intercepts. They're the value that fall along the horizontal. All right. Now, if you look at your calculator, you don't see the Y or the X-axis anywhere. So that's where we're going to adjust our windows so we can use our calculator. So when I go to window, it looks like I'm going to, maybe the intercepts are over where my fingers are on either side. So I'm going to need to make my Y or my X values a little bit bigger. So I'm just going to go from -1 to 1. I'm not sure how long it takes for the ball to hit the ground. Here we were looking at 0.36 seconds. So from -1 to 1, that probably will give us what we're looking for as far as our height value or our time values. But look, if the ball is on this axis right here, we're trying to find the time where the height is 0, right? This is going to give us a t, but a y value of 0. So I can't see it here because 0 doesn't fall inside that range for my y's. So maybe we should do something like -1, I don't know, we'll just make it 3 and see what we can see. So that's how you kind of have to play with your window. So when you hit graph, you're going to see a different version. Okay, so those were our points that were plotted. And here we go. Now we have a nice window where we can see the tennis ball. Now it asks for the T-intercepts of your model. So we have 2 here. So to find these intercepts, we want to put one side into y1, and the other side is going to have y2 equals 0, because that a T-intercept means you have a t, but the y value is 0. So that's in our y equals, we already have y1 filled in. y2 is going to be 0 because, again, we're looking for what t values make the y value 0. So essentially we're looking at this. When does the quadratic, look back to see what it was, -13.727, 13.724 t squared plus 6.232 plus 1.979. When does that equal 0? What time value gives me height equal to 0? okay? So there's two. Now, one's not going to make much sense, right? But you've got to trust that they want both when they ask you for the intercepts plural. So to find out where those two functions cross, right, we put this into y1 and this into y2. We're going to use our intercept. So I'm going to hit option 5 and then 1, 2, 3. Okay, there's 1 point of intersection. So negative 0.215 comma 0 is 1 t-intercept. And then I'm just going to use my arrow key to let my calculator know I want this one that's on the right. So you just have to be closer to it than the one on the left. And then 3 enters. 0.6695 or 0.67. How about that? So these are the two time values that give us a height of 0, okay? So these are the time values that give us a height of 0. Which means the ball hit the ground. Now the first one says time is negative 2.15. That makes no sense, right? We can't have a negative time value. So this one provides us with some model breakdown. This one, however, is a perfectly reasonable answer. So after 0.67 seconds, the ball hits the ground. Now, they want to know, and this is a question I pulled off of my math lab, they wanted to know when there was model breakdown. So I'm hoping you'll see that model breakdown would occur any time to the left of time t equals 0, because you can't have a negative time when we're talking about throwing a ball. And then from this point on, we're going to have model breakdown because this would be a negative distance. This would mean like if this was ground level, the tennis ball broke through the sidewalk and kept on going down. That doesn't make any sense. So there's two cases where we have t values where there's model breakdown. So any time values that are less than 0 gives us model breakdown, right? This doesn't make any sense. You can't have a negative time, right? That doesn't make any sense. And the other model breakdown would be after the ball hits the ground, right? Here, you can't have a negative distance. So after this 0.67 seconds, that's where we're also going to have some model breakdown. Right? The path of the ball is from here to where it hits. So anything beyond that is going to be model breakdown. Now, when they're asking about the maximum or the minimum, that's when they're looking for the vertex. Right? And the vertex you can find with your calculator. So if we go up to Calc, if in doubt, go to Calc. We're looking for option number 4, which is the max, and we just need to bound it. So you need to get your cursor to the left of your graph, of your vertex, and now we've got to get the cursor to the right of the vertex. That's what the bounds mean. And then at guess, we always hit enter. So it looks like the max, so here I'm going to write down the vertex and then we'll interpret it. So that's what the calculator told us the vertex was. So the input is time and the output is height. right? So the ball reaches a maximum height of 2.687 feet. Oh, they barely threw it up. They kind of just pitched it, did a little lob after 0.227 seconds. Okay, so those are the keys that I wanted to cover. I wanted to talk about turning a plot on. I wanted to talk about Zoom 9, which is Zoom Stat. It'll make a window that will plot all of those points. I wanted to look at the intersect key. And I wanted to look at the max key. All right, so hopefully that makes some sense. We'll work on it some more, but there's 2 MyMathLab problems that have multiple parts, but they shouldn't be too terrible. Make sure you give those a try, and we can talk about them in class on Monday.